to Atoms to Bits, my platform and integrated projects to dive into issues around digital spatial intelligence for building owners, AEC professionals, and reality capture specialists. So today I'm talking with Austin Corotan, Director of Engineering here at Integrated Projects. Cool. Nice to have you join me, Austin. Thanks.
Yeah, great to be here.
Cool, thanks a lot. So, Austin, I was Googling you this morning. Bachelor of Geophysics and Computer Science. It sounds pretty interesting. Also, like a bachelor's in astronomy or a minor in astronomy. And then you took that on to a master in science and computer science, which when I started looking through it, it looks hellishly interesting. Robotics and AI, computer vision, machine learning, deep learning, data visualization. This is yeah, ridiculously exciting. And then the experience that you got with that is like water quality in Hawaii or GIS data with NOAA. That's quite an exciting kind of intro.
Yeah. My background, kind of a bit that had my hand in a lot of different, a lot of different things. Started off doing geophysics, kind of moved more into, kind of in my time doing astronomy. I kind of got really into software as well, which kind of transitioned over nicely into, computer science. And I always kind of, I was, doing some just independent tinkering of, with ML and things like that beforehand. And so I thought it was, something to jump into in grad school too.
Very cool. Very cool. And weird, you got into software from astronomy, you said, not the other way around. Not you started with software, you started with computers and
So it actually kind of doing it, for astronomy kind of brought it back. I've been really programming for a long time from a young age. It was really started with robotics. And that's where I really back, I think it was, when I was 13, 14 years old. And then I took a pause on programming. I really enjoyed it. And then, kind of a few years down the road in college, really got back into it. And it was kind of, it really started with, kind of like that data science application to astronomy data.
okay.
So it was less building software and more using scripting to analyze astronomy data and to try to come up with insights there. So
Cool.
that kind of showed me, there's a different application to coding and programming, which kind of sparked my interest.
Yeah, for sure. And that kind of brings us to why I snagged you in today, because like machine learning and AI, there's talk about it everywhere. And now I've heard about it and I've picked up a little bit, like I'm kind of self-taught a little bit. But I'm pretty sure like I've only got half the picture. So if let's say you're one of our users or you're kind of interested listener, you've heard about AI, you've heard about machine learning, deep learning, they all fit together somehow. But why are there different names? What's what? And what is it that you want?
I think these terms get thrown around a lot, and I think it is up to some interpretation, but generally I think how I see it is really like AI is kind of like the all-encompassing term for just generally exhibiting like intelligent behavior, so algorithms that can do that. And so really machine learning is kind of like a subset of AI, focus on the actual learning aspect. I think there's some there's a few other algorithms outside of, I would say, like the ML bubble that would still be within AI. I think things like search algorithms and things like that apply to robotics. And among others. But ML is really generally focused on I would say, yeah, like the actual algorithms for learning,
Hmm.
and for exhibiting, like, yeah, the predictive analytics. Um, and deep learning is kind of, again, like a subset of that, which is kind of like the evolved form of machine learning. It takes it a step further,
Hmm.
with neural networks and more complex algorithms.
Cool, cool. And so, like how complex does it need to be an AI? Or so machine learning, I think I understand what it is, but like I'm not sure of that. But sorry, I'm babbling. Like when you get like what makes it AI? When you go from an Excel spreadsheet with like a formula, which is the sum of things, at some point, like I get that at some point you're trying to train an AI to do something, but there's an in between, and there's a whole lot of just straight algorithms which are not much different from a formula in an Excel spreadsheet. How does something become
Mhm.
AI rather than like the maths that I'm using the spreadsheet?
Yeah, I think I yeah, I definitely think both are very valuable, and it's something that, I think using a combination of both, even in cases where ML applies really nicely, I think is, yeah, still a really good thing to do.
Mhm.
But in general, I think, yeah, with ML, you I think it's great in cases where, um, I think where it the data is complex, like too complex to code up these deterministic rule-based kind of programs.
Mhm.
Um, so things like if you're looking for scale, I think if you're trying to solve a task that, right, is tedious, you have to do it at scale, and that's complex, right? That
Yeah.
can't be, yeah, that essentially can't be, deterministic, or there's just too many factors to analyze. This is where I think it comes in really nicely, where you can start to kind of dive into like those relationships between these factors and between this data. Um, and so really, yeah, that's kind of focused on, yeah, the relationships between these complex factors, predictive analytics. But I think, yeah, there's that other side that's kind of more like a exploratory analysis, where you're just kind of doing, simple formulas, but they go a long way, averages, aggregations,
Yeah.
filtering. um, yeah, and that's just as important for insight, I think, especially in our case too.
Yeah, for sure. So our case and insights are two things. So like I was just reading your research work on kind of precipitation and weather and such. That's vastly different to reality capture and the kind of work that we're doing. And not necessarily just reality capture, but um, kind of the industries we're in general. So there's reality capture, which is central to us, but there's real estate on one side and there's construction on the other. Um, how is AI breaking into kind of these spheres? Like I hear a lot of talk about it, and I hear a lot of kind of I see a lot of research at kind of university level. If you want to look at point cloud segmentation, it's all university level stuff. It's not commercial level stuff, but it's becoming more commercial quickly. Is it just about point cloud segmentation? What else should we be interested in that machine learning can be helping us with?
Yeah, I think, right. I think point clouds are just kind of, yeah, I think it's just one aspect of building data. And I know, yeah, point clouds right now, that, yeah, everything surrounding point clouds, that's kind of the main, yeah, kind of like application, close to what we're working with. But there's other types of data in addition, like in addition to the point cloud, there's just kind of like the building metadata. And if as we build our database of buildings,
Mm.
right, these buildings have certain properties that are not necessarily just right, just the geometry, and those that metadata could be something that we could look into to do, yeah, predictive analytics on. Um, I think one thing would be, for example, like, yeah, if a user maybe knows certain information about their building, but doesn't have the digital twin for that building. Maybe they have just certain metadata about that. Could something be said just from those parameters based on our analysis of buildings that we've already modeled, or maybe even within their portfolio? Can they, I guess, interpolate, or can we interpolate any information based on our previous work? So it's kind of like, there's that building metadata, there's the geometry, and I'm sure there's other parameters too.
Yeah, but it's looking into the models and trying to kind of glean whatever data you can get out of the models. So when we're looking at BIM, it seems to be way easier that at least there's metadata either within the model or kind of around the model. And like, at least you know that a wall is a wall, and at least if you're aggregating areas, they're tagged as areas. That's almost way easier than, like, I know we're not doing like proper semantic segmentation now, but point clouds themselves, as far as I understand, point clouds are like the poster child for complicated machine learning, because the data it's really simple and ridiculously unstructured. And so it's very hard to deal with a set of points that have only got like X, Y, Z, RGB, and that's it, then a list of points. It's way easier to deal with something that's tagged as a wall or tagged as an area.
Yeah, for sure. And I think there's a lot of because of that, there's a lot of pre-processing that goes into, I think there's dedicated work just into the processing of point clouds and just getting it ready to even have these algorithms be applied to it. I mean, it's not as straightforward as just kind of using doing machine learning on tabular data. There is kind of that level of complexity.
And so it's all about data science. So if you know what AI is and machine learning and deep learning, then if you've missed out data science, which kind of wraps the whole thing, am I right about that? That data science is, it's almost one level up from AI. That, well, I suppose it's not necessarily AI, but it's looking at this data and figuring out what to do with it. Is that it? Is that, well, and is that actually what we're trying to give to our users? We're trying to say, if you apply data science to this, then you can get a whole lot of insight. We've just got to see how you apply the data science to it. Is that right?
Yeah, I think so. And there, I think there's there's things that we can do, and I think there's things that we can empower our users to do themselves. And maybe there's something like giving users the flexibility to dive into the data, maybe giving them certain tools to dive into the data and kind of realize those insights. But really, it's not just machine learning, it's not just predictive analytics, but it's also just diving into the data, doing that exploratory analysis, just trying to see if there's trends or correlations within the data. And that's all something that's can be done with simple formulas, and the approach is pretty straightforward.
And that's something we're kind of trying to do as well. Like, if you wanted the tools to dive into the data, we're trying to do that. That is what we're trying to do with IPX. What kind of tools do you need, or how would you dive into the data? If you're a user and you've got a portfolio of buildings, what is that going to look like? How do you, what tools do you have, you think?
I think a big part of it is being able to view. That's one. So having a way to view the actual geometry of the building, being able to see, I guess, see the relationships between the elements in the building, but also I think, yeah, so yeah, having the model is a great thing, but I think there's also things we can do to, I guess, simplify that experience. Maybe we, like looking at different data aggregations, but also I think it's a combination of simplifying it, but then maybe, yeah, providing users with the flexibility to dive as deep into the model as they would want to go. And yeah, just I guess kind of really like yeah, the providing the information in kind of like a consumable, yeah, kind of like that consumable format.
Yeah, yeah, because
But
what you were
it's
just saying of kind of simplifying, like simplifying the experience and simplifying the data. What you're always going to have is, if you're looking at any kind of BIM model, any kind of model, whether it's point cloud, the BIM model, step one is that you have too much data. So step one, you've got to kind of filter it out to find what you're looking for. You have to start filtering for a start.
yeah.
Mm.
Yeah, I think, yes, simplifying it down. Yeah, yeah. Just providing that way for, yeah, for users maybe to, not only, right, like dive into a singular building, but maybe even, comparing between the two, or comparing between multiple, might be something interesting on like a portfolio level.
And is this a thing that we can use machine learning for? Are these, yeah, other machine learning tools, can you throw that at this and get insights? So like what I'm wondering is like, aside from BIM and integrated projects, is like all the hype around machine learning, and there's a lot of it specifically around reality capture. Like where is that pointing the user? Like what should the user be interested in or diving into to get the most out of what's possible with machine learning these days, or AI in general?
Yeah, yeah. I think, yeah, it's, I think, yeah, right now, yeah, with when it comes to, machine learning applied to these, yeah, they're building data. I think it depends on what our data set looks like what information do we have. If we know that, right, there's, if as of right now, I think if we only have a certain number of parameters, a certain number of factors, maybe machine learning might be like an overkill, or might be, yeah, not the best approach. But as we start to build our data set and, start to realize, yeah, there's more, right? There's more information out there. I think things like, yeah, like the energy analysis, yeah, things like that, where now we're bringing in kind of some of these outside information, and so now we kind of have this new data that's related to the building. As those parameters start building, I think we'll start to find that yeah, this building data is more complex, and maybe too complex to, right, to kind of extract actionable, or yeah, extract insight, and just kind of in a coded sense, which is when we can maybe start to look at applying machine learning. But really, we would need enough data. Yeah, when we have a certain number of parameters, we'll need enough data to actually be able to train these algorithms and to do something useful. So I think it depends very much on, yeah, what information do we have, and what are we looking to get out of it?
Yeah. So I suppose in a general sense, for machine learning, yeah, in general, like you say, when we've got enough data, typically you would use huge amounts of data to train an AI to do anything you want like ridiculous quantities of data, like in order to train the AI. Which you're saying, like just with a set of BIM models, you're not likely to get. But once you start adding in climate information or embodied energy information, then that kind of the data that we've got around a building or around a set of buildings starts to grow. I wrote down in my notes. So on one hand, you want to look for opportunities in AI. On the other hand, you want to be careful about diving into the hype. And it's the thing about complexity, isn't it? So that you've got to kind of choose the right tool for the job. And while AI is an exciting tool, make sure that you've got the right problem for it. And these like you want complicated problems.
I think it really shines where the problems are complex and where you have a lot of data.
Mm-hmm.
There's also, right, even within ML, there's certain tools that excel right more than others.
Mm-hmm.
I think the earlier ML algorithms, are I think there's some that are better at smaller data sets, especially especially with deep learning is when you really, I think when you're looking to train these huge networks, is when you really need like a lot of data.
Mm-hmm.
And there's some that are better with minimal amounts, but yeah, even within that, I think taking a step back, it's we really have to kind of figure out, I guess, when would be a right time to apply this, and if we would even need it, based on what we're trying to what we're trying to show.
Yeah, absolutely. I wonder where it is that you get the engineering time you'd have to put into any problem is no doubt huge. So the problem's got to be worthy of that. And I wonder, well, is it when you get to digital twins? So when you're going that, okay, point clouds is one, but as we go through the BIM process of modeling, get once you've got a digital twin at the end, and especially if you've got a portfolio of buildings of digital twins of your buildings, perhaps with real-time sensors, then the opportunity of getting loads of data which you can throw at your AI, like that's when you have loads of data available. You just have to figure out what the best use for it is, or find problems where this is the best solution. Yeah.
I think I mean, as I think what we're doing, and I think the digital twins serve as like a great like kind of backdrop to right to including more information, and as we start to kind of aggregate that information from different sources, I mean, I think there is a point where I mean, it would be complex, but the key would be we'd kind of have to set up like those data pipelines to be able to properly aggregate and clean that data and prepare it for for predictive analytics. And if that data is messy and it's not, we don't have the same set of features for each building, it's going to be a lot harder to do really anything kind of with that. So that's kind of like a big factor here. Especially since it seems like a lot of the data in the industry it's coming right now, it's like kind of coming in from different like siloed places, and like not every so I think in general people don't have access to every piece of information about their building in the same way. Certain buildings, they might have certain information that just they either didn't they didn't hire the service or they didn't need that information, and so maybe for certain buildings it's missing, and for some it's there, but Yeah.
And that's going to throw any analysis off like crazy, surely. Whatever it is that you're trying to analyze, the like emissions of your building or embodied energy of your building. Um, yeah, every single building, no doubt, is going to have some unique. Like if you're just looking at energy, there's multiple ways you could be getting your energy. So is this like the data scientist has to take this incoming data? Yeah, and you were saying clean it, but that's where it gets complicated because in the instance, like in our industry, if you're going to kind of throw out buildings which don't have the right kind of electricity input to give you clean answers, you're going to throw out too much data. Um, that's when you look, yeah, when you're looking at portfolios of buildings and the size of the data set. No matter how big a company you are, an individual company is going to have a, a handful of buildings or a few hundred buildings at the outside maximum. Even if we've got quite a nice data set of buildings, it's still a few hundred to a few thousand buildings. It's not like we're not going over a few thousand by a long way, um, which makes life complicated. That's a tiny data set from your point of view. So
Yeah. Yeah. So yeah, that's tricky. I think there's probably some tool or some algorithm out there that does play nicer with smaller data sets, but really, yeah, it's kind of, yeah, I think we need to kind of take a step back and kind of see what data we have,
mhm.
what do we want to do with it, and yeah, what's the best tool for the job. I think that's what's good. That kind of requires, like a whole, yeah, kind of a whole study in and of itself.
Yeah,
And I think it's going to require some combination of, I think, yeah, people who are versed in machine learning, but also industry, right? Industry experts as well that um, are able to, yeah, that have that kind of, know the data a little bit better and might be able to have some insight on how we can maybe pre-process this data.
yeah.
Um,
Yeah,
yeah,
and of course, you don't want to start off with a solution and go out searching for the problem that you're going to solve, like with this machine learning. So, if we can do machine learning, that's fantastic. Let's go and figure out what we can fix with it. Is the wrong way around. You should have, like, we should get a problem in front of us and figure out the best tool, as opposed to having a tool and going to go find the problem. Um,
yeah,
on on this kind of machine learning, that's BIM at the almost at the end of the process. The semantic segmentation and creating BIM out of a point cloud. Um, I think you can do it without much human involvement. Do you think you can do it without much human involvement?
yeah. I think it's a tough one, but I think, yeah, I think it can be done. Maybe a good first step would be, yeah, exactly, to try to minimize human involvement rather than just completely replace it.
Mm-hmm.
Um, I think there's a few points in the processing of point cloud to BIM where maybe, yeah, like kind of like having that right, the human like augmented approach would work really well.
Yeah.
Maybe there's certain parts of the process that, right, where we find like, yeah, maybe doing the segmentation and doing the machine learning to or whatever algorithm to make that happen um, might be, yeah, um, that might be easier, but then there might be parts where it's like, yeah, maybe it's just more simple for a human to draw a bounding box around the outer walls of the building real quick, and then pass it to, right, pass it to some automated pipeline.
Mm.
And I guess it's just kind of diving into that and really understanding, I guess, which parts can we look to automate, and then even within the point cloud itself, identifying, what are these current algorithms really good at
Yeah.
identifying, and what are they not? Maybe we'll find that MEP is much harder to automate than the outer walls or furniture even.
Yeah, fair enough. Yeah, and what I think is it's the small things. So the point cloud is always going to have a certain amount of fuzziness to it, like in terms of camera focus, which doesn't matter when you're looking at a wall or a floor slab, but it matters an awful lot when you're looking at a table leg or a piece of furniture. And what I think is that while there might be like quite simple algorithms to segment out the big planes like walls and floors, then you're going to get down to collections of little things, which are chairs and tables and computers and bookshelves and things like that, which like which is going to be way harder to just blanket say all the vertical planes are clearly walls and we can just cut them out now. That's fine for the beginning. Then as you get into the detail, this is actual traditional machine learning, right? You're going to have to give the AI a whole bunch of toilets to look at so that it knows what a toilet looks like, and then be able to recognize that in the point cloud. Does this point cloud of a toilet or a basin look like what it's expecting? It's how successful is that, and how or how complicated is it? Are you going to have to give the AI something for, like, well, sure you will, for every single object that it's going to learn?
Yeah, so I think it from what I've seen, yeah, like these classification algorithms work really well in cases where you're able to like kind of well define those classes. And so if we're, I think it's much easier to say, hey, like classify this object into one of these 10 classes versus, yeah, like I guess identify what this object is just based off of, anything. You almost need to kind of have, based on the limitations of these algorithms, you kind of need to have those classes. So if we're able to, say like, rather than say like, so like really like, I guess kind of dumb it down to, chair, desk, just like very simple objects, and then being able to classify within those categories is a much, I think, easier problem than, yeah, kind of having hundreds of classes that you'll have to do, and and it is possible, and there's algorithms that there's that can do things like that, but I think if the more constrained, we can be, I think the more powerful these algorithms and more accurate they are.
So that's yes, I can. So give the algorithm like like big enough sizes of categories for it to divide something into.
But we might not. And I guess it's kind of looking at what we're producing and trying to see. I mean, if we're able to hone in on those classes, like, is that enough? And do we have a solution for cases where, maybe these objects might fall without, like, kind of, out of any of these classes? What would we do in cases like that?
And I imagine the problem with BIM, which might be different in other places, is the segmentation of it rather than the semantics of it. So where does wall start and floor, like floor finish and wall start? Or is the problem with point cloud specifically compared to kind of 2D video or 2D plus depth video? What I'm told is that point clouds, like, they're kind of unbounded. It's not, if you're looking at a picture on a screen, you know the pixel count quite easily, and you can allocate a pixel anywhere. We've got sparse point clouds that we're dealing with. There's a lot of blank space in between us, and whether a piece of blank space is something not scanned, or whether it's air which was scanned, or where the whole point cloud starts and ends, and where the wall that you're trying to segment starts and ends. It's more complicated because we're doing the whole thing in 3D. Is that right? Or
Yeah, I would agree. Yeah, I think it really with data like point clouds or any sparse data, I think the way that the data is encoded really, yeah, I mean, plays a huge effect on right the performance and the capabilities of some of these predictive algorithms.
Mhm.
Um, and so yeah, I think that's why there's kind of huge effort surrounding the library, even just the libraries to kind of process these point clouds. Because yeah, typical methods of dealing with sparse data might not be appropriate for yeah for some of the analysis that we're looking to do.
Mhm.
And so yeah, I mean, it's just in general, I'd say that's a really key aspect is yeah, how that data is consumed by the model. Um, and yeah, and I think point clouds are kind of tricky in that sense. But I think there's a lot of novel. I'm not an expert in in point machine learning with point clouds, but there's a lot of libraries that have been released recently that kind of extract out the difficulties of consuming point clouds, and as well as yeah, kind of implement some of these kind of state of the art neural networks for classification and segmentation of them.
Yeah, for sure, for sure. But is it that is it just that it's way easier for us to think of use cases with point clouds than with the rest of the BIM process, or the rest of the kind of real estate or AZ owning process? If you're looking to use AI or machine learning, you need to have the problem worthy of it. Now, point cloud segmentation, that's obvious. It's like if you can do point cloud semantic segmentation, it's going to be with some kind of AI. Whereas once you get like, if you've got a portfolio of buildings together and you want to see what you're doing with that portfolio of buildings, you're you're not necessarily going to have AI use cases tripping over themselves to get you. That like the use cases are almost few and far between for now, at least. I imagine this is going to change like, as we go into the future.
Yeah. Yeah, I think especially yeah, as we start to learn more about what data is available when it comes to just this information. I know, yeah, I mean, yeah, there's companies out there producing a ton of different data points, but I think yeah, it definitely is uh, right. Yeah, it's easier for us to kind of wrap our heads around machine learning applications to kind of like the geometry to point cloud information. I know there's been a lot applied to kind of like the automation of like layouts and design, just design in general. Has I think that's also been pretty popular. Um, but
Yeah,
yeah,
we haven't spoken about that at all. Hey, there's like
yeah.
the people who are designing with AI, they're doing some pretty great things, aren't they? Um, what have you been looking at like that? Is this what kind of test fits are doing, or that kind of thing?
Yeah. So I think I've that's what I've come across in some reading is yeah, when it comes to like test fit and kind of like yeah, that plan and arrangement of a space. I think I've seen applications of generative adversarial networks to that problem, um, as well as I guess uh, the extraction of uh, like I guess 2D information from point clouds, as well as has been one.
Mm-hmm.
Like yeah, like the CAD lines. as well. Uh, yeah,
Yeah, and
yeah,
that seems to be pretty successful. The CAD lines from point clouds, that works pretty well, the ones that I've seen. So I wonder, are they just trying to look in 2D? Is that like, have they just simplified the problem? Is that why drawing it in CAD or these things work pretty well? Because if you just look at it in a 2D plane, then you can do it.
yeah. I think they simplified it. They kind of removed that extra dimension. I'm not exactly, not exactly certain. Uh, yeah, like I guess what makes it easier other than some like the obvious of kind of simplifying it. Um, but it is interesting, and I think it's a good kind of first step and really promising approach to kind of producing some of these information and these plans from kind of that raw data. Um,
Yeah.
yeah,
Yeah, that's it. Try produce information, but try and make that information clean enough that that doesn't take a human double as long afterwards cleaning up what the AI did.
yeah,
Uh, that's the goal, really. That's the goal there. Yeah, and yeah, I would say it's like at the bottom of my list of things. It did digital twins. I have to say, aside from learning point cloud, which is great, I have the sense that if you own a bucket load of buildings and you've got 10 buildings, you've got sensors inside of them, getting all of that data kind of into a digital platform and analyzing it constantly. It might not be machine learning on day one, it might be machine learning eventually, but getting all this data about your buildings, seeing where you find like where is the insight or the value within that data, because it's great to kind of collect as much information as you can about your asset, but that can be pointless and it can just cost you money. But what you need is insights if you're a building owner. And I'm guessing that's where these computer algorithms are going to help us. I don't know how yet though.
yeah. I think really, when it comes down to it, I think with all of this, it's trying to understand, like with the data, like I guess what does what does this mean? What is my data trying to show me, and how can I use this to kind of inform my decisions? Um, and so it's kind of seeing what I mean, every use case is unique to the individual, but maybe there's a certain subset of information that's useful across all use cases. And maybe that's something we can kind of look to. Maybe there's some standardization there. I guess what's the most useful information we can look at, but maybe machine learning isn't necessarily like the best approach when it comes to just sort of like the simple information, the tabular information about a
Mm,
building. But I think it's more geared towards the more complex automation tasks.
yeah, fair enough.
But yeah,
Yeah, but whatever tools you need, getting that information out of your building, yeah, that's the idea. Whether it's a simple tool to get to look at tabular data, or whether it's something more complex, yeah, it's about choosing the right tool, really, isn't it?
yeah. I think something interesting too, and this is maybe not just applied to BIM, but it's just to like data in general, is kind of like the use of these, maybe incorporating the use of some of these language models
Mm-hmm.
that have really kind of hit the mainstream. Um, maybe
Like what?
like going from like like simple like language to some sort of query or some sort of information might be really useful for kind of um, having the power of the data, but also simplifying it. So, for example, like asking, just simply asking a question like, how many chairs do I have? And then being able to extract a number or to provide a number back.
Yeah.
So converting that natural language into a query into that information being returned to the user, I think could be really powerful. And it could be a really powerful way of, I guess, kind of diving into a data set. And it might be really useful for, especially when it comes to information about your portfolio of buildings. I'm not sure exactly, like what questions users would be asking, but if we can hone in on, I guess, even just kind of like the format of how those questions are being asked, then we can, we can essentially tune these large language models to, to kind of simplify the data.
Because we've got it in, like you say, if we understand the formats of how those questions are asked, we can't understand all the questions that could possibly be asked. So, geez, I'm way out of my depth. How the hell do you jump from understanding the question to be able to make that query? Because now you're going to be making like a potentially infinite number of queries of the data, depending on kind of the input question. How the hell do we get that to work? Or
I think there's from what I've seen, and I've only kind of tinkered around with it, but with some of these large language models, you can tune them by providing examples. And so so if we provided, for example, like 10 or so examples of different questions and how those how that question relates to let's say maybe like a query that can that correlates to actual an actual action on the back end of the platform, then the language model can start to recognize, okay, this is a question about this information. Now I can pass this parameter. And I think we can also structure, we can kind of provide a guide, I guess, or like kind of like a formatted way to go about asking these questions. I could see like with the combination of not just like an open text entry, but maybe like a set of drop downs or something like that to kind of steer users into kind of asking these formatted questions. But I guess it's really how do we have, maybe not like necessarily we have to show every parameter of every building in our data set, but how do we I guess give our users the power to ask questions about their data by however means that they would want, and kind of provide a simple way to ingest the information that they're looking for. Because it's with we I think we have a lot of, between the geometry, between the metadata, we have a kind of a lot of different data points that we're presenting.
And actually visualizing that data is a whole separate kind of issue. Visualizing 3D BIM data is kind of easy, but there's all sorts other than a 3D model. Like how you're getting that data out and then visualizing it over the top of a 3D model on the web, all sorts of different data. It's not straightforward, is it? But it depends on what you're asking. What data are you looking for? What,
I think, I mean, we're also kind of limited in the sense of, what can we, I guess, show in a presentable way on our platform. So I think being kind of clever about how we're providing users access, but right, kind of hiding the complexities or kind of the unnecessary information to not overwhelm. I think that balance is, kind of something we're kind of.
It's almost like a
grasping.
complicated balancing act, because like you want to go, you can, like, we want to show you as much data as we can about your building, but we also want to make it simple and legible and easy to navigate. It's a fine line between that, give you as much depth as you can and make it legible.
Yep.
Yep.
Yeah.
Cool, Austin. Thanks for talking to me. There you go. We're up to an hour, so it's quite easy to talk about something for an hour. And I really don't know about the stuff. I like dabble in it, and I've read a whole lot, but AI is complicated. So yeah, I've learned a fair bit. Thanks very much for sharing.
Yeah, for sure. I know we're just, we're just kind of starting to begin to think about how we can right, like, is this something we can use? How can we apply this to our data? I know we really haven't done too much of a deep dive. I think this is like a really good kind of introduction to this, and kind of like maybe how we can start, how we're thinking about it, and how we can begin to kind of start to organize maybe how we can take advantage of these tools.
I look forward to figuring out. Yeah, absolutely. I'm sure we've got big projects ahead of us on all of this.
Yeah.
Cool. Well, thank you for joining me on Atoms to Bits. I hope we get to start like LinkedIn conversations and get people interested in talking about this stuff, and then we can learn from everybody else out there as well. So yeah, cool.
For sure. Awesome.
Cool. Okay, thanks very much, Austin. Yeah, cheers. Thanks for being on the recording.
Yeah.
Cheers, man.
Thanks. See ya.
Yeah.